In this problem, we have to determine the equivalent resistance between the terminals A and B. So look at this circuit. In this, A and B terminals are on this side. So equivalent resistance means we have to determine the total resistance in the given circuit. So we have to simplify this circuit. So in order to determine the equivalent resistance of the given circuit or total resistance in the given circuit, across whichever terminals, across A and B terminals, we have to determine the resistance. So just look at the opposite side of these terminals wherever you want to determine the equivalent resistance. So opposite to AB is what? This side is the opposite side. CD, wherever CD is there, that is the opposite side. Now look at the CD side. There is a resistor of 75 ohms, and if you carefully observe this, okay, carefully if you observe from K to L, if you carefully observe, if suppose current is has started from node K, and if it has started to flow through 25 ohms, current direction will change here and it will flow through 75 ohms and the current will return back to L. So when the current is passing through 25 ohms, okay, whatever current is passing through 25 ohms, same current will flow through 75 ohms. When same current is flowing through two elements, those two elements are said to be connected in series. So since these two elements are said to be connected in series, where series connected, if I want to determine the equivalent resistance of series connected elements, what I should do? I must add those resistance values. So I have determined the resistance between K and D. Resistance between points K and D is what? Simply you have to, since 25 ohms and 75 ohms are connected in series, simply add those two resistances. 25 plus 75, you will get 100 ohms. Okay, so we have added these two resistances. So we can replace these two resistances with a single resistor of how much resistance? 100 ohms. So you see, in between K and L already 100 ohms is there. Here I have added one more resistor in the next diagram, and whose resistance value is 100 ohms. This is our modified circuit diagram after simplifying these two series elements. Okay, so after determining the equivalent resistance of these two series elements, this is what the resistance that we have got. Okay, we have to determine the overall equivalent resistance across terminals A and B. So just for these two series elements, I have determined some equivalent resistance, which I have got by simply adding these two resistances. 25 plus 75, I have got 100 ohms. So we can draw a single resistor whose resistance value is 100. Now if we observe this circuit, now you just observe these two elements, this 100 ohms and this 100 ohms. If you observe at node K, you just observe what is happening at node K. These two branches are dividing. If current enters from 50 ohms, if current enters, okay, through branch 50 ohms, through this branch 50 ohms, if current is entering at node K, then current will divide into two parts. If current is dividing into two parts here, since these two branches are having common point at this, and these two branches are having common point at this node, so these two branches are said to be connected in parallel. Okay, what will happen if current enters from this 50 ohms resistor at this junction K or node K? Current will divide into two parts. Since current is dividing here, or in other words, based on the theory that I have already discussed, what I can say that this 100 ohms and this 100 ohms front end points are connected at a common point, and back end points are connected at the common point. So these two resistors are said to be in parallel. Or what we can observe is that if current enters at K node, then current will divide into two parts. So 100 ohms and 100 ohms are connected in parallel. Since they are connected in parallel, we can further simplify. So 100 ohms and 100 ohms, the resistance between K and L is 100 ohms and 100 ohms are connected in parallel. So resistance value, equal resistance is 100 into 100 by 100 plus 100. You just calculate this, you will get 50 ohms. Now what is the resistance between K and L? It is 50 ohms. So instead of drawing these two resistors, I can replace these two resistors by a single resistance of 50 ohms. So that's what I have modified here. You can see this diagram I have modified, and I have redrawn the diagram. In between K and L I have written 50 ohms. Okay. Now once again let us see, in between K and L 50 ohms is there, in between G and K 50 ohms is there. So whatever current that enters at node G, that current will divide here in between 100 ohms and 50 ohms. Whatever current flows through 50 ohms, same current will flow through this 50 ohms also. Okay, current flowing through GK and KL is same current will flow. Of course current direction will change, but same current flows through this 50 ohms and this 50 ohms. So we can say that this 50 ohms and this 50 ohms both are connected in series. So if I want to simplify and determine the equivalent resistance of GL, resistance between GL, equivalent resistance between GL, simply add 50 plus 50, you will get 100 ohms. So what is the resistance between G and L? It is 100 ohms. So you can redraw the diagram. Okay, add in, write L here, but the resistance between G and L is 100 ohms. Now if current enters at node G, what will happen here? Current will divide into two parts, and some part of current will flow through this 100 ohms, another part will flow through this 100 ohms. Okay, so means these two 100 ohms resistors are connected in parallel because current is dividing here. So you just simplify it, you will get 50 ohms resistance. So resistance between GH, equivalent resistance between G and H is 50 ohms. So instead of drawing these two resistors, you can replace by a single resistor of 50 ohms. So our modified diagram is, where is it? So our modified diagram is this. So resistance between G and H is 50 ohms. Now once again you just observe this circuit. If current enters at node E through 25 ohms, okay, so what will happen here? Again current will divide. Some current will flow through the 100 ohms, some current will flow through 50 ohms, same current will flow through this 50 ohms. So the resistance between EG and GH are connected in series. So these two 50 ohms are connected in series. So simply add those values, you will get 100 ohms. So what is the resistance between E and H? It is 100 ohms. So you can remodify this diagram and you can draw it again. So this is the 100 ohms resistor. Now if current is entering at node E, what is happening? It is dividing into two parts, means the resistance 100 ohms and this 100 ohms both are connected in parallel. So just simplify it, you will get 50 ohms. Okay, so what is the equivalent resistance of these two elements? It is 50 ohms. So replace these two resistors by 50 ohms. So the modified circuit diagram will be somewhat like this. Now if current is entering from terminal A, the current will flow through 25 ohms and current direction will change, and same current will flow through 50 ohms. There is no element here, so no, we need not bother about it. So current flowing through 25 and 50 ohms is what? Same. So these two elements are said to be connected in series. So 25 plus 50, I will get 75. So the modified circuit diagram is 75 ohms. Okay, so this is the modified circuit diagram whose resistance value is 75 ohms. So they have asked us to determine the resistance between AB terminals. We have got the resistance between AB terminals, that is 75 ohms. Now let us go to another numerical problem. So if you look at this diagram, it is a bit complicated, but it is very easy. Now here they have given three equal resistors, R, R and R. Okay, all the resistance values of all these three resistors is R, and their connection is as shown. You have to find the equivalent resistance between A and B. Between terminal A and B, you have to determine the equivalent resistance. Now if you observe here, okay, if you carefully observe here, in between this node and in this node, there is no element. There is no element here. So you can join this node with this node. Okay, you can join this node with this node. If you join this node with this node, okay, if you join this node with this node, you can observe the other end of this resistor is connected here, other end of this resistor is connected here. So let us assume that these are the finishing ends of these resistors and these are the front end of these resistors. Okay, so since their front ends are connected and finishing ends are connected, okay, so these two resistors are said to be connected in parallel. Or you can assume current direction. You just assume current is entering at this node, so the current will divide into two parts. Current will flow like this, and it will divide and it will flow through this, and these two currents will add here and enter this. So if there is no element here, it is almost short circuited. Okay, so this short circuit they didn't provide across one particular element. They have provided a junction here, you can see in between. So we can't say that these resistors are short circuited. You just assume, you just join this dot D dot with this terminal, that will show both the resistors are in parallel. Now you just observe this resistance and this resistance. This C dot is there, and here this one terminal is there. Okay, so whatever current enters here, it will divide here and it will leave here. It will, whatever current entering here, it is leaving this node also. So here current is leaving, here also current is leaving. That means both the resistors are in parallel. So R is parallel to this R is parallel to this R, means all these three resistors are in parallel. It is bit complicated to understand, but you must assume some current directions to understand the concept. So as I have already told you, the resistors, if they are connected in parallel, their front ends will be connected to a common point and back ends will be connected to a common point. So here a small confusion has been created by providing this connecting line, but you just assume the current direction and try to understand. So based on the discussion, what we have understood is that all the resistors are connected in parallel. So 1 by RAB, resistance between AB, is equal to 1 by R plus 1 by R plus 1 by R. Okay, that is equal to 3 by R. So what is RAB? RAB is equal to R by 3. Okay, so let us go to next problem. In this problem, they have asked us to determine the resistance and power dissipation of the resistor that must be placed in series with 75 ohms. So you can see a circuit. In this there is a 75 ohms resistor and R is there. R value is not given, but they have asked us to determine the power dissipated by this R. How much power is dissipated? P is equal to V into I. Power is equal to voltage into current. Must be placed. Okay, so this resistor is placed in series with 75 ohms resistor across 120 volt source. Okay, source voltage is given, that is 120 volts. Okay, and this resistor is dissipating power in the form of heat, that we already know, and this resistor the power dissipated. Okay, so the power dissipated in 75 ohms resistor is given, that is 90 watts. So power dissipated by 75 ohms resistor is 90 watts. Power dissipated by this resistor we have to calculate, and of course we don't know R value, that also we have to calculate. So now these two are connected in series. That's what is mentioned in the question. R and 75 ohms are connected in series. So what is the equivalent resistance here? Equivalent resistance is R plus 75, both are in series. So total series resistance RS is what? R plus 75. Okay, R plus 75. I have mentioned here R1 notation I have given to 75 ohms. No need to write R1, you simply write R plus 75 is the total resistance in the circuit. So what is the current flow in the circuit? I equal to V by total resistance. V is what? 120. Total resistance is what? R plus 75. Now what is the power dissipated in 75 ohms? In 75 ohms power dissipated is given, that is 90 watts. What is the P is equal to V into I. and you can write P equal to I square R. What is the R value? 75 ohms. So I square into 75 is equal to P. P is what? 90. So I square into 75 into 90. This is it. Okay, simplify it, you will get I value. Okay, if you know I value, you can calculate R value. Okay, what is R? R equal to 120 what is I equal to 120 by R plus 75. Now we have determined the I value. Substitute I value here. So if you substitute I value, 1.095 will be equal to 120 by R plus 75. You can determine the R value. Now R value is 34.6. We know I, current is same because both elements are connected in series. So what is the power dissipated? I square R. I value is 1.095 whole square into what is R value? 34.6. So you just simplify it, you will get the power dissipated by this resistor, unknown resistor R.